and thank you everyone to join this webinar. In this webinar, I will go through the new features of the Compute Server v9, and I will also make a live demo at the end. So before going into the details of the new feature of the v9, I'd like to introduce the Compute Server itself. So the Compute Server is a way to seamlessly offload optimization tasks to one or more servers. So you can start different computers where you run the compute servers, and you can join the compute server together to form a cluster. On the client side, you can submit optimization tasks, and those tasks will be load balanced into the cluster, and if there is not enough capacity in the cluster, they will be queued. This is useful in many situations. For example, you may want to share resources across users, teams, or applications. You may want to use more powerful machines that you have on your network. You may want to ensure high availability of your solution by using multiple nodes, so that if one node fails, then another node can continue to work. You may also want to build modern application where you know that a dedicated service will be in charge of the optimization. So in v9, we have introduced a lot of new features for the compute server. For the IT, we provide an extended architecture that is scalable. We have improved the security, and we provide a new web user interface to manage your cluster. For the OR experts, we have the new web user interface to monitor your jobs and monitor your batches and so on. We have also a persistent job history that lets you look at what happened in the past. And we introduce a new mode to process your optimization task, which is a batch mode. In this batch mode, you can submit a model and disconnect from the server, and later on retrieve the results. And you can see in the screenshot on the right that we have this new web user interface that we call the cluster manager. So in v9, we facilitate the deployment and use of optimization services on premises and on cloud. So let's review some of the architecture that we support. And there are many ways to deploy the cluster manager and the compute server. And let's review the different options that you have. First of all, we support in v8 and also in v9 what we call the self-managed cluster. In a self-managed cluster, you can start compute server nodes or distributed worker nodes. Distributed worker nodes are used when you run a distributed algorithm such as distributed MIP or concurrent MIP. So you have many of those nodes, and you can join them together and form a cluster. The clients then can connect to any of those nodes to submit their task. It is a very easy way to install the compute server and very powerful, but it also has some limitations that we wanted to expand on with the v9. First of all, when you set up this type of architecture, the configuration has some properties, and some of those properties may be the same throughout your cluster. For example, the passwords. The nodes must be accessed directly by the clients, and the nodes must know what are the other nodes so that they can be joined together. Also, the job history is stored on each of the nodes, and if you remove one of the nodes, then you will lose the history related to that node. Finally, the clients must remain connected during the optimization. In v9, we introduce a new component called the cluster manager. The cluster manager sits in between the clients and the compute server nodes. It provides authentication, authorization, API management, and a web user interface. It also relies on a database, a MongoDB database, to store the user accounts, the history, the batch, model, and solutions. So on the client side, you just need to connect to your cluster manager. You don't need to access directly the compute servers. Everything is going through the cluster manager. On the backend side, the compute server nodes do not need to know what are the other nodes in the cluster. They just need to join the cluster manager. This architecture can also scale. If you want to handle many more client connections, then you can set up a load balancer in front of the cluster manager, and you can have multiple instances of the cluster managers. The database can also be deployed as a cluster on multiple nodes. And of course, on the back end, you can have many compute servers or distributed workers connected to the cluster manager. In the V9, we have improved a lot the security, and we have introduced a new user management feature. So with this, system administrator can create and manage accounts for each user. The users can provide their own passwords, and users will need to log in to access the web UI. They also need to log in to access all the features using the command line tools or through the API. We have defined 3 different roles: standard users, admin users, and sysadmin users. Standard users are able to submit new jobs, and the administrator can kill any job from any user. They can also access to the licenses. The system administrator can do all the above, and in addition, can manage the users and other system attributes. When you install the systems, the system of a compute server and cluster manager, it will create automatically 3 users: Gurobi, admin, and sysadmin, one for each role. And you can quickly use the cluster manager and connect to it and use it. Of course, before deploying for real deployment, remember to delete those predefined accounts. For the applications, we have introduced also a better security using API keys. An API key is composed of an authentication token and a secret key. And you can see an example of that in the screenshot on the right. Each user can manage their own API keys. So each user can create, delete the API keys. And those API keys can be embedded into the applications. This is to avoid having to share the login and the password for a given user inside an application. Finally, for security, we manage encryptions, and we support HTTPS over the wire. And here you have 2 options. Either you can have the cluster manager terminate the HTTPS and TLS on the cluster manager, and then you continue using HTTP within the protected environment of your network, or you can open encryption using HTTPS everywhere. The system administrator has a view in the cluster manager to list all the users, and the system administrator can create, delete, or change passwords of any user. The system administrator can also list and delete any API key. The system administrator can also list all the nodes that are connected to the cluster manager, and for each node, you can know the address, the type of the node, is it a compute server or distributed worker, if the license is valid, if the node is accepting new jobs. You can check how many jobs are in queue, how many jobs are running on that node. You can also see the job limit. The job limit indicates how many jobs can run at the same time concurrently on this node. You also have a live update on the memory consumption and the CPU usage. There is also a specific view for the licenses. And so with this view, you can check each node and what type of license they do have. And for example, you can check if there is an expiration coming soon, and again, what are the attributes of your licenses. Not also that with the V9 we support floating token server licensing. So that's a new mode that we have added in V9, and that's what we are using in this screenshot, where you see that each node is using a token. So with V8 and V9, we support a mode to submit your optimization task that is called interactive optimization. With interactive optimization, the client is always connected to the server, and the client remotely controls all the optimization steps. So the model building, setting the parameters, the optimization, accessing the results, and so on. All that is controlled by the client. And the client, again, needs to be connected to the compute server from the start to the end. There can be some intermediate network problems, but there is a keep alive going on between the client and the compute server to make sure that the connection is still there. If the client dies, then the job running on the compute server will also terminate. So this is supported of course, was supported in V8 and is still supported in V9, and that's a major way of using the cluster manager. And to do so, you need to connect to the cluster manager. And to do so, you have some parameters to connect to the cluster manager that can be set in the client license file. And there are some new properties. The first property is a CS manager that is used to indicate the URL to the manager. You can also use the CS API access ID and CS API secret to specify your API key and secret. You have another option to use username and password, but we don't recommend using that mode because in this case, the password will be saved in clear in the client license file. A better approach is to use the login command, where you specify your username and password, and the cluster manager will return an authentication token. This token is secured and stored into your client license file. So here is an example. If you want to connect to a manager, you can type grb cluster login -- manager, and you provide the URL to the cluster manager, and you also provide your username and password. And then once this is done, you're connected, and all the command line tools, such as Gurobi CL or grb tune, and grb cluster as well, will then use those parameters automatically. You don't have to specify those parameters again. If you use the API, you have similar parameters. Here, this is an example in Python, where you can set the parameters CS manager, CS API access ID, and CS API secret. Once you have submitted the job, you can monitor and access the history. So you have in this screenshot, you see on the left that you have 3 sections: the cluster jobs, the queue, and the history. If you look at the cluster jobs, you list all the jobs that are running in your cluster, or that are recently completed. And for each job, you know when it started, what was the user who submitted that job, you know the optimization status, the version of the client used. You may want also to indicate which application submitted that job, again, the duration, the API type, and the algorithm that was used during the solve phase. In the queue section, you can take a look at what are the jobs that are in queue and that will be executed soon, as soon as there is capacity in the cluster. And if you want to look at what happened over a longer period of time, you can take a look at the history, where you can query what was executed. You can filter by user, by time period, and so on. You can access the logs of your jobs, and there are 2 cases. Either the job is still running, and in that case, you can have a live update of the log and see what's going on. And if the job was completed, then it is automatically archived into the job history, and you can retrieve that log very easily. In V9, we have introduced a new mode which is called batch optimization. It's a way to run non-interactive tasks. In this mode, you need to follow 3 steps. In the first step, you build a model and you submit. And then the cluster manager will return a batch ID. The batch ID is then used to reference your request, and you can monitor the status of your batch. When the batch is completed, then you can retrieve the results as a JSON file. So this new mode has a lot of benefits. The first thing is that the clients can disconnect in between the steps. So you can build a model, submit, and then disconnect. There is no resource being used once you have disconnected on the client side. Also, the results can be retrieved later on and can also be retrieved by a different client or different service of your client application. You don't need to have the model that you created in the first place when submitting to interpret the solution. And I will explain that in a minute. So in terms of architecture, how does it work? First, you build the model locally and you set a specific property called CS batch mode. This will tell the environment that you want to use batch mode for that model. Then you call a new API, optimize batch. And this will create a batch inside the cluster manager and provides an ID to reference the batch. Then all the model and all the parameters are sent to the cluster manager and stored into the database. When there is capacity in your cluster, then the job will run. And once completed, the solution will be stored back into the database. Finally, the client can retrieve the solution as the solution and the solution files. You have to know that to save space, models and solutions are transferred and stored compressed throughout the system. Building a model for batch optimization is a little bit different from building a model with interactive optimization. In addition to building the model, you also need to tag your variables and constraints. This is because only the variables and constraints that are tagged will be, only those variables and constraints will be exported in the solution. So it's a way to filter what you want to export. It's also a way to map your business entity and the variables. So when building the model, you need to think about that and assign tags to those variables such that you can read your solution and interpret your solution to build your business solution out of it. And this is pretty powerful because you can interpret your solution standalone. You don't need the model context that was used in the first place. Let's take an example. Let's assume that you have a typical assignment problem where you need to assign worker to shifts. In this type of problem, you will have a binary variable to represent the assignment of one worker to one shift. And the tags that's pretty straightforward. You can assign the tags with the worker and the shift that relates to a given variable. Here we use a JSON as a format for those tags, but you can use any other ways. The tags are just strings, and you can use a CSV or another format as you want. But of course, we recommend using JSON as it is very easy to parse and when you get the solution. So here, as you can see, we tag each variable with a small JSON object having two properties, one for the worker and one for the shift. So you build this model, you tag all your relevant variables, and then you call the optimize batch API, which will then return the batch ID. And here is an example of the solution. In this example, you can see on the right the JSON formatted solution, where you have some general information about the solution inside the solution info section, and then you have an array of variables. This array will contain all the variables that have been tagged, and you can see the value of the variable with the X attribute. And you also can retrieve the tag in the vtag property. And you can see that inside this vtag, we have a string which is formatted as a JSON object that contains the worker and the shift. So when reading this file, you know that Amy, which is a worker in this first line, has been assigned to the shift Wednesday at 8 a.m. So to summarize, you once you have submitted the badge, you get a badge ID. You can monitor the badge status, and when completed, you get this solution file. Very easy to parse, and it will contain all the information that you need to build back your business solution. You can also submit batches through the Cluster Manager Web UI, and you can see a screenshot of that view, or you can use the command line, and you have a specific command, grb cluster batch solve, and you can provide the model name and which type of result you want in the result file parameter. This will give you the batch ID, and you can then later on follow and monitor this batch and get the results. In the Cluster Manager, you have a specific view for managing the batches, and you can monitor what's going on. You can list all the batches that you have into your system, and you can see if they're completed, if they failed, if they are still running. And you can know what was the model name, when it was created, when it was submitted, when it was completed, which user submitted that batch, and again, other properties. One of the properties is also very important. This is the size. The size indicates how much space is used in the database to store that specific batch. And in the same way, as jobs, you can take a look at the logs, and the batches can be retried. So in case there is a system issue, then you can click on the retry button and it will rerun the same batch. In addition to the batch, we have another feature which is called the file repository. This is a way to upload model files or parameter files into the Cluster Manager, and then you can reference those files. You don't need to upload them again. So if you have examples or if you have something that you want to share between your team, then you can upload that, and people can access them and reference them without having the need to upload them again. Finally, we have a REST API to integrate the Cluster Manager into a custom environment. This REST API covers all the entities that I've talked about. So the user, the API keys, the nodes, the history, the batches with the model and solution files, and so on. You have access to everything. All the features that are exposed in the Cluster Manager can also be accessed through the REST API. So now I will go through a quick demo. I will show you how to install the Cluster Manager and how to start two nodes and connect that to the Cluster Manager, and I will show you the different views that we have. Then I will submit a simple job, and we can see how to log in, how to submit the job, and how to display information into the Cluster Manager. And finally, I will show you how to submit a badge using three ways, using the workforce batch example that we ship with the distribution, and also how to use the web UI and the command line. So I will now share my screen. So here you can see that I've prepared several windows. On the top left, I will have 4 tabs in this window where I will start the database, the cluster manager, and the 2 nodes that we want to run. Note that I will run all that into my laptop, so everything will be running in the same environment. This is just for demo purposes. Below that window, I have another window where I will run some client commands, so to submit batches or jobs. And on the right, I have a browser where I will be accessing the cluster manager. So the first thing to do is to start the MongoDB database. MongoDB is pretty easy to install on the different platforms, on Windows, Linux, or Mac, and it can be started as a service, but also here I'm going to start it manually, and this is as simple as starting this command, MongoDB. Next step is to start the cluster manager. So once you have installed the server package on your machine, you have access to one executable, which is called grb_rsm, which is the executable of the cluster manager, and you can check what version you have by using the option --version. You can also learn about the different commands that you have using the --help command, and you can see all the options and all the commands that you have. Here, what I'm going to do is just start grb_rsm, and this will connect to the default location of the database on this machine automatically. And at that point, I can already access the cluster manager because we have the server running, and you also see on which port it is running. It is running on port 61080. And so this is the I can show you. I can zoom in and I can show you that I logged in. I was actually logged in, so I'm going to log out, and you can see that you have the login panel, and that's what you will typically see in the first place, and you provide your username and the password. And again, the default installation comes with 3 default users that you can use right away, and you can sign in, and you can see here the different section provided by the cluster manager. You have a section about the jobs, about the batches, about the cluster, and about the accounts. So in the accounts, you can see the 3 users I was talking about: admin, Gurobi, and Sysadmin. In the cluster, you see that there is no node at this point, and the license also is empty. So now let's connect one node and then 2 nodes. For that, I am in my demo directory, and I'm going to create a directory called node1. And I go to that directory. Then I'm going to use a command of grb_rs to initialize that directory with default settings. And so grb_rs is the executable that is used to run one given node. And I'm using, but before starting, I'm using the init command to create all the settings and configuration and so on. Once I've done that, I can set my license, because to run a GRB RS, you need a license, and I have a license file prepared for my laptop here. And then you can start GRB RS by indicating to which port you want to run. Here I'm going to run the first node on port 61,000, and I want to connect to the manager running on port 61080. And here I have one node, and you can see here that on the cluster manager we have already one node connected. I'm going to do the same thing for the second node. So I create the directory, I go into the directory, I init this directory. I'm setting my license file, and this time I'm going to run GRB RS on a different port so that there is no conflict, and I'm connecting to the same manager. And you can see that now we have two nodes connected to my cluster manager. So let's take a look at what we have here. As I explained before, we have two nodes. Those are two compute servers. They are accepting. The job limit is 2 on each of those nodes. And we can see that the memory and CPU usage is updated. And I can also check that I have some licenses on each of those nodes, and the type of the license in that case is node. So now that we have the system set up, let's try to submit a job. To submit a job, you first need to log into the cluster manager. And you do that by using the grb cluster command. GRB, and let's check that we have access to the GRB cluster. So you can type GRB cluster --version to make sure that you are using the latest version. And now I'm going to connect to the cluster manager with the login command, and I can provide the manager address and the username I want to connect with. Because I didn't provide the password on the command line, it will ask securely for the password here. And you can see that it created a session that will be valid for several hours. And during that time, I can access the cluster manager without giving again all the connection parameters. And then I can use GRB cluster, GRB tune, and Gurobi CL in the same way, and I don't need to again provide those parameters. So let's try to submit a sample model. Here I would say Gurobi CL, and I'm providing the Glass4 MPS file. And you can see that it's running. You can see the node just marked as running. There is one job running here. And if I go into the details, I can take a look at the job panel and cluster job, and I see that one job is running. And I see all the information, and I can take a look at the log as well. And you can see that the log is being updated live while it is running. From there, you can abort, you can download your job, and you can get back to the list of jobs that you have running into your your cluster. I have nothing in queue, but here you would see if you send a lot of jobs to your nodes, you will see the status of the queue, and you can take a look at the history. Those are jobs that I ran today and yesterday, and you can see when it was started and what was the optimization status and so on. So you can again access all the metadata and the logs of all the jobs. Now I'm going to show you how to submit a badge. And there are different ways to submit a badge. The first one is by using the command line. When using the command line, you have, let me clear that window, the client window, and you have a special command in Gurobi cluster to submit a badge. It's the badge command, and then you can say solve, and you provide an MPS file. Press this now, it will create a new batch, upload the glass4.mps file to the cluster manager. It will create a batch job to execute that batch, and it will return here a batch ID. This is my batch ID. So with this ID, I can monitor the batch. I can check the status, if it is still running or if it has completed, and then I will be able to retrieve the solution. So let's take a look at the cluster manager. We should see here that there is one batch that is running, as you can see, submitted. You can abort. You can take a look at the log as well, as we can with a job. And you can see in the details at the bottom that we have an input file, which is the glass4.mps that was uploaded. And now we have also the glass4.sol file that was generated. And you can download this file from the API, from the command line, and also from the UI here. I can just click and I can get the solution file. The second way to submit a batch is to use the cluster manager, and here you can drag and drop input files. You can set up, for example, here I can do that. I can also specify what result I want. So here, to do the same thing, I will indicate the solution file, and then I can press the solve button. Again, this will run this batch. I can show you that you can abort. Let me click on the abort, and it will abort the batches right away. Finally, and that's the main way that you should use the batch feature is using the API. And there is in the distribution, there is an example called workforce_batch_mod.py. So it's a Python example that shows you how to use the batch feature, and we can go through quickly what is going on in this code. Here you create your environment, you set your batch mode to 1, and you start your environment. In this function here, submit assignment problem, it will create it will build the model, tag the variables, and submit the model, and then we'll get the batch ID. From the batch ID, you can wait and see the status, and when it is completed, you have this new API on the batch to get the JSON solution. So let's try that. And this is as easy as running this Python workforce batch model.py. And that's it. This is the batch that was already submitted, executed, and this is a display of the solution. If I go back to the cluster manager, I see that there is a new job that already completed. The model was assignment.mps. And what's different here is that in the input, you can see that we have sent or uploaded 3 different files. One contains the MPS file, the other one all the parameters, and the third one about the attributes. The attribute file contains all the tag information that you have added to your model. In the output, you have the solution file, and you can download it here, or you can get it from the, of course, from the API. And we can actually take a look at the solution file here. You have again a section giving information about the solution globally speaking, and then you have this array of variables where you have the tags and the value of the variable, and so you can read this file and parse this file very easily in any computer languages, and parse that and build back your business solution out of the tags and the value of the variables. And so I think that's it for the demo. I think we have reviewed all the main features of the cluster manager and the Compute Server version 9. So let's start a Q&A session.